All right, I'm back again, physics guys. I'm going to go through the example problem. And the example problem talks about the characteristics of a sound wave. And the sound wave has a frequency of 192 hertz. Um, it travels a distance of, or has a displacement of 91.4 meters, which is the length of a football field. And then it travels that distance in 0.271 seconds. So it's pretty darn fast. Here's the idea. They're asking what's the speed or the velocity of that wave, what's the wavelength, and what's the time period. Now, I'm going to cheat, and I'm going to do time period first. I know that time period is the inverse of frequency, okay? Or frequency is the inverse of time period. So I'm just going to write this down, and I'm going to say, well, if I already know it's 1 over the frequency, I'm going to say it's the inverse, or 1 over 192 hertz, okay? And I know that time period is in seconds, right? It's going to tell us how many seconds it takes for one whole cycle of a wave. Now, when you put that into your calculator, you know that the time period is 0.00521 is what it says, or 0.00521 seconds. So the wave's moving pretty darn fast. Okay, there you go. And what this says is, what that frequency says, is there are 192 waves, back and forth per second. So that is pretty fast, and it has, to complete one whole wave, it doesn't take that much of a second to do it, and that makes perfect sense. So let's go back to the beginning. Let's say, okay, well, I want to know what my speed is. Well, I have my distance and I have my time. So if I say the distance traveled, total distance traveled, and it only took 0.271 seconds, and that's meters per second. Simply do the math, divide 91.4 by 0.271, and you come up with approximately 337 meters a second. Makes sense. Sound travels pretty darn fast, doesn't it? Right? And so the only thing you need to know is wavelength, or lambda, and we already knew, because I showed you in the previous video, that to find the wavelength you need to know the velocity and you need to know the frequency. Well, you've been given the frequency and you've found the velocity, so the velocity is 337 meters a second over a frequency of 192 hertz. Okay, and when you do the math for this, you'll come out with, I think it says 1.76 meters. Did I get that right? Yeah, I did. Okay, so there it is. A wavelength. This is, has length in the name of it. It's got to be in meters. Time period has to be in seconds, and velocity is always meters a second. So now you know how to solve these things. The last thing says, what would happen if you changed the frequency? Well, dear God, if you change the frequency, look what would happen. It would be even a tinier bit of time if you raise the frequency. If you raise the frequency here, the waves get even shorter, right? So this became 400. It'd be less than a meter for every wave, and heaven forbid we do that, because once we get this wonderful, the speed remains the same, but when we work with the speed and change the frequency, shorter waves same speed, and a lot less in terms of time period. Got it?